Welcome back to the weekly news Roundup. We are going to have to talk a little bit about passwords and passkeys and stuff like that because, they told us, you're going to switch from passwords to MFA. That's perfectly secure. And yeah, we're going to get into a new method they have of getting around that one, which actually I found wasn't even a new method. It was presented to me as a new method this week. And I started researching security of passkeys and I found that the new method this week was talked about by security researchers last year. Interesting. And then, of course, you got to get away from all that to Passkeys, which carries with it several fundamental flaws. And, oh, yes, DEF CON just showed strategy to bypass passkey authentication as well. So, we're kind of screwed here. What do you do? Well, I think the best we can do is minimize our accounts and be very vigilant about what and how we are signing into. So we'll go ahead and start with how attackers are bypassing your MFA. Of course, multi-factor authentication, sometimes called 2FA. Of course, that's, two factors. This is multi-factors because you can secure an account with multiple different alternative ways. And in fact, one of the passkey arguments people say is having MFA in addition to passkeys inherently introduces a security risk. Go figure that one out sometime. But it's true. It is true. We have to be more vigilant than this, and maybe we need to have a society that has less accounts, So this is called Evil Gen X. Obviously a play on words from Nginx, one of the web servers. So Evil Gen X is an attacker in the middle phishing toolkit that sits between you and real world websites, relaying genuine sign-in flow. So you land on a page that looks like Microsoft's sign-in page. And so you are expecting certain behavior. So you enter the username and the password, and just like Microsoft, it boom, pings you back, multi-factor authentication code. And then you enter the multi-factor authentication code, but really what this is you're on some scammer website that's just feeding that information back to a command and control server, which is then tied to the legitimate login. So they're able to bypass your 2FA codes. And, what's the number that comes through? You enter the number, they take that number and they put it right on into the site. And now they have bypassed your MFA and now they have an actual legitimate session token for your account. So, this is what those guys in India are trying to stop, right? And so they're able to use the session cookie and bypass the MFA by passing through the security challenges. Now, this would not work as well if you're doing something like a YubiKey. So if you're doing a hardware key two-factor, it would not work. If you're doing a passkey, it would not work. But that's actually where one of the attack vectors comes from. We'll get into that in a moment here. But the attacker sends you a link to a fake page that looks exactly like the same. For example, a bank login page, web shop, or your email or company's single sign-on page. In reality, the page is a live proxy to the real site. Evil Gen X isn't just stealing your login. It also captures a session cookie. The attacker can reuse it to impersonate you, often without triggering another MFA prompt. And so that really is the concern here. And so, okay, sure, I'll accept the terms for some site that's going to clear its cookies. Why not? But this actually article is pretty good here. So passkeys are not attack-proof, not until implemented properly. This is an excellent article because it really covers a lot of the is this the one I was thinking it was? Oh, no, this one is. Okay, we'll get to this one, though, first. So passkeys are not attack-proof. This is where we actually saw that first instance of Evil Gen X. And note that this is in July of 2024. But it's talking here about poorly implementing your passkeys, like offering a backup. So ask yourself this question: what happens if I lose my passkey? Well, you have to have an alternative way into the account, right? Well, what these guys are arguing here is that if you're implementing your passkeys with a less secure backup, it can still lead to the Evil Gen X attack in the middle, or adversary in the middle attack, bypassing the authentication flow using the procedure that we had just discussed. So the finding means accounts believed to be safer behind passwordless passkey authentication, such as on online banking. I wish online banking supported cat passkeys. Most of them don't. E-commerce, social media, cloud accounts, software development platforms can still be broken into. Passkey redaction for GitHub, Microsoft Access, through detailed POC, Stewart noted in the blog that open sourced adversary in the middle software like EvilGenX can be used to hoax users of popular IT services like GitHub, Microsoft, and Google. They were basically to bypass it. Why? Because in this case, if your passkey doesn't work, you have a backup means of getting into your account, right? That's really what they're getting at here. So it further emphasized that most of all the backup authentication methods, ones used on top of passkeys, are prone to the adversary in the middle attacks. These include passwords, security questions, push notifications to trusted devices, social trusted contacts, recoveries, code over SMS, email, phone, know your customer document verification, or magic link. Basically any way other than the basic passkey, can get into the account. All right. So how do you back it up? Well, you multiple different passkeys is a great option. We'll get into why that's a challenge here in a moment. But ultimately what they're saying here is, yeah, passkeys are this deeply secure thing. However, what happens if you lose your passkey? This is my fundamental problem with what Microsoft is doing, because they're forcing this passkey type system onto people, but they don't know what it is. They don't know where the passkeys are stored, and they have no idea how to access that account in the event their current computer or whatever device they're having breaks down. And we're going to get into why that is a problem. But first, I want to cover this. I'm going to move my article slightly out of order because the passkeys are not clearly perfect here. So users unaware their passkeys are hijacked in DEF CON 2025. Leave it to a bunch of crazy Las Vegas hackers to figure this one out, right? So they say the passwords are the internet's weak points. The passkeys are the golden rule. Nope. Technology is not without its flaws. At DEF CON 2025, researchers from SquareX revealed a vulnerability that can undermine the entire system, showing that browsers can be manipulated to intercept or forge the authentication process. So by doing some form of malware on the browser, they are able to bypass the authentication or pass your passkey authentication down through the phishing site, just like the adversary in the middle attack. Isn't that wonderful? So attackers can exploit the passkeys. Attackers can register fake keys, bypass biometric checks, or force users to re-register their passkeys under an attacker-controlled environment. In practice, this means the threat actor would have unauthorized access to bank accounts, SaaS platforms, and cloud services. So effectively, in this instance here, what they're saying is you go in, and you've done this before. Like I have one of my payment processors, for whatever reason, they're still stuck in like 1999, and every 3 months they want me to change my password. They haven't gotten the note that like 5 years ago, the organization that puts together passkeys said stop requiring people to change your passwords all the time. Only change it in the event of a breach or some necessary thing. But people are so trained to do this frequently that they're using passkeys. They enter the passkey and go, well, you have to re-authenticate your passkey. Oh, okay, I guess I got to re-authenticate my passkey. So they go and do some re-authentication because the average person does not even know how passkeys work most of the time. They're just like tied into it, and they have no earthly idea what they're doing or how they're doing it. And so what ends up happening is the attacker in the middle on the browser ends up registering a passkey into the account. And so they have effectively taken over the account with a passkey. Well, go figure this one out. But that's exactly what they're saying the exploit happens to be, all because technology companies have trained us so many times. We got to re-register keys. We got to redo our passwords. We got to re-authenticate ourselves some other way, even though I've been authenticated for 16 years, happens all the time. So the problem is not the cryptographic method of the passkey. That right now remains intact. I think they're going to crack that eventually. But that right now remains intact. But the browser itself can be intercepted for it because you need to use the passkey tied to something, tied to a browser. And so we have some fundamental problems. Now, I wanted to cover this article here last because this person here makes some absolutely amazing points in this article from Ars Technica, and this is Dan Gooden. And so passkey technology is elegant, but it's most definitely not usable security. And this is an absolutely incredible article. If you only want to read one article of everything I do tonight, this is probably it. So using the same password everywhere, of course, is easy, but of course it causes a lot of breaches. Using different passwords through password managers, you get that. Of course, now everyone wants us to use the passkeys. And the problem is, again, most people just do not know how all the passkeys systems are working. They don't realize that your Microsoft account is going passwordless. Your new Google accounts, they're trying to push you passwordless. They're trying to put you onto the passkeys. And the problem is that passkey is tied to some physical piece of hardware that most people don't even know exists. Like, I have passkey devices in my OneKey, and I have passkeys registered on accounts, which I can use those in addition to other means of authentication. So, my accounts here, I don't have any phone numbers on my account. People go, oh, you're going to have a phone number with YouTube. You got to have a Gmail account with YouTube. No, you don't. They do not have a phone number for me. They do not have a Gmail account for me. I have passkeys, and I have 2 separate MFA security tokens in addition to that. One is locked in a safe in case something goes tragically wrong, and the other 2 are available as physical hardware keys, which are themselves locked behind further cryptography. And so there are ways you can do this right. The problem is, as he gets into in this article, is that every single device you're on wants you to use their default means of doing the passkeys, which is where the fundamental problem comes in, because I don't know where that passkey is if I'm an average non-tech person. I just know I got my brand new Windows 11 computer, and then the first thing I'm doing is I'm frustrated because I don't know where my Wi-Fi password is. And so now I'm like, Johnny, can you come over and help me set up my computer? And then Johnny comes over and he remembers where the password for my Wi-Fi is. So he gets that. He puts the password in for the Wi-Fi. Great. We're awesome. We got it. And then, we get into the next phase. You set up your Microsoft account. I don't have a Microsoft account. Well, I guess you got to get a Microsoft account now, Grandpa. Where's that password? You don't have a password. It's so amazing. You just look at this pretty camera right here. It just logs you right on in. What happens if you shave? I don't know. But then you have this passkey authentication system, which is in your computer and in your Microsoft account, which they're making passwordless tied to the computer. So if your computer TPM module dies, you have no other means to get into your account. Of course, we know setting up that password for that backup is radically insecure and prone to those adversary in the middle attacks. So you can't possibly do that. But it gets worse as he gets into. So he says he likes the technology, and I agree that technology is good if we could have a sane means of implementing it. And that's the problem. Even if you want to use the passkey system in KeePass XD, I'm still forced to use the browser extension, which itself found itself vulnerable. Not KeePass XC's, but everybody's browser extension was similarly vulnerable to certain types of attacks. But in order to use passkeys in KeePass XC, I have to use the browser extension, which means if I'm on an Android device, I can't use the passkey inside of that because there's not a browser extension for KeePass XC, because there's not even an official KeePass XC app that supports passkeys that I'm aware of. And if I'm wrong, let me know. We're talking on an Android device. And so the FIDO2 specification is the overlapping web-auth predecessors underpin passkeys, nothing sort of pure elegance. Unfortunately, as support has become ubiquitous in browsers, operating systems, password managers, and other third-party offerings, the ease and simplicity envisioned have been undone. So much so that they can't even be considered as usable security, a term I define as a security measure that's easy or only incrementally harder to use as a less secure alternative. Why does he do this? Well, because he says that this massive difference in ecosystems has fostered a jumble of competing workflows, appearances, and capabilities that can greatly vary depending on the particular site, OS, and browser agents such as native iOS and Android apps. Rather than help users understand the dizzying number of options and choose the right one, each implementation strong-arms the user into choosing the vendor's preferred choice. Then he kind of gets into what he's doing down here is he gets into when you're signing up, like, for example, if you're using, and I think he uses PayPal as an example down here. If you're using PayPal in a Windows computer, it will utilize the TPM module and tie that to your Windows Hello so you can smile at the camera, enter your PIN or press your fingerprint on there, and that will be a passkey into PayPal. The problem is if you need to then use PayPal on your phone. Well, Windows Hello's not there anymore, and now PayPal's like, hey, we need a passkey. Like, what? Now, this is where they're trying to be like, well, verify on this computer and then enter the code over here, or verify on the computer, we'll give you a QR code to scan with your phone. Well, what if you're logging into your PayPal account at your friend's house and your computer's not sitting there? That's where he's getting his fundamental challenge, because then he gets into it that every single application, every single app, every single device wants you to use their preferred means, which means there is no cross operating system compatibility among passkeys that easily works. If you had a single dongle and you could plug that dongle into the phone, into the computer, whatever else, and everything worked, passkeys would be absolutely amazing. People understand you have a passkey, it's on this device. They should sell passkey fobs in packs of 2. Set up both of them here, put one of them in your safe, and keep one of them on your person. Solves the problem, but nobody wants to do that because Google wants you to use theirs in the Chrome browser, Android wants you to use theirs in the Android system, iPhone wants you to use theirs in the iPhone system, Windows wants you to use theirs in Windows Hello, and Mac wants you to use theirs inside of the iCloud account. And then, of course, some of these want to cross-sync all of your passkeys to the cloud, and that is where your fundamental hack is going to come from. So he gets into this, he says, it's more complicated if I want to log into LinkedIn on Firefox for Android and presented with the following dialog box. You're using on-device encryption. Unlock your passwords to sign in. Now, he says down here, at this point, I do not know if it's Google or if it's Firefox that's presenting me this non-intuitive response. I just want to open LinkedIn using the passkey that's been synced by 1Password. So he's using 1Password, which in theory, using 1Password should be easy to do. But apparently it's not. And so he says here, somehow, let's see. He says, I just want to open LinkedIn using the passkey that's synced by 1Password to all my devices. Somehow, the mysteriously entity responsible for this message, and he says in this case it's Google, has hijacked the process in an attempt to convince me to use its platform for passkeys. Also consider the experience on WebAuthIO, a site which demonstrates how the standard works under different scenarios. When a user wants to enroll a physical security key to log in on Mac OS, they receive a dialog that steers them towards using a passkey instead and to sync it to the cloud. So use the Touch ID to sign in. The passkey for this site will be saved in iCloud keychain and available on your device. Or you got to click the button down here for other options. So if he says I'm using synced passkeys inside of 1Password, I have to go all the way down into other options in order to get that to show up. All right. And so what I see over here then is now he ends up clicking the other button. And then once you click that button to go other options, it still defaults you to the iCloud keychain. Because it's Mac and it wants you to do that. So then he has to go down and click the security key button, sign in with a security key. So he basically says here the problem is the issue of too many cooks in the kitchen. So most funnel you to the vendor's sync passkey option and don't make it clear how to use other things. Brown noted that Chrome, Apple, Windows all force you to use their synced passkeys by default, and you have to click through prompts to use the alternatives. He says this seems to have failed the make it easy for users test, which in my view is the whole point of passkeys. He complained that passkeys implementations to date lock users into platforms they created credentials on. That's my problem with Windows. Okay, that's the problem with Windows. Okay, we have Windows. It wants to automatically put all your passkeys on that one particular device, on that one particular device, one particular TPM module, which of course could go bad. So then he mentions down here, More helpful still is using cross-platform password manager to store and sync passkeys. He says he's been using 1Password to do that for months with no problems. Most other name brand passengers likely perform as well in keeping with FIDO2 specs. These credentials are end-to-end encrypted, which of course you can do passkeys with KeePass XC, but of course you have to have the browser extension installed in order to get into work. But honestly, they work out pretty well. But this is the fundamental problem that we see with the entire passkey system. Passkeys are great if implemented properly. The problem is every single platform and every single browser wants you to use theirs. You're on an Android device, you enter a site that wants a passkey, it wants you automatically to save a passkey on that device. I don't want to save it on that device. I want to have one simple set of using passkeys, and there's no easy way to send that. And that's really where the problem is that we have a giant, massive mess of passkeys. And until that issue is solved, passkeys are not a viable option for a standard person. Your standard user, your standard grandma, grandpa, Uncle Charlie, whatever else, you know what? They cannot navigate. Like, I can't navigate half the time, and I know what I'm doing. Okay? That's a problem. So let me know your thoughts about that. Of course, the whole stream is linked down below. Thanks for watching, and I hope that you enjoy switching to Linux.